Yeah, that after you got a chance to watch the recordings, because I think you are the only one a few lectures missed.
Yeah, I missed out last 2 weeks. Few have gone through, not completely, but I'll catch up. Like,
Cool. Perfect. All right. Let's just do a quick revision of what we did last lecture. Last lecture, we majorly started with our type 2, which is exotic options. We had completed type 1, so we had started with the kind of questions, the categories of questions that can be asked for Black-Scholes. We had started with type 1, which was the main formula-based question, which was a piece of cake for you all to do. We had the formula of Black-Scholes model. We can be given all the parameters, only one parameter will be unknown. The easiest or the most difficult was to calculate call option, put option price. The most easiest was to actually calculate strike price, risk rate, volatility, if any of those parameters are unknown. The approach that you take over there is the trial and error based approach. As I said, minimum 2 tries, maximum 3 tries. We had discussed what the starting points are going to be, and then once you have your final iterations of the test, just interpolate, and if it doesn't come in your range, extrapolate and write the answer. That's the type 1 based question that we did. The type 2 questions as well we completed, which was nothing but exotic options. This we understood with much more clarity last lecture when we did it afresh. We can do this using 2 approaches. The first approach is I express my exotic, or rather, let me put it this way. You can be given any word problem. The first step is to identify what does the payoff diagram look like. When do I get the payoff? When is not there a payoff? When the payoff is 0, so on and so forth. The next stage or the second step that you need to ascertain is, given this payoff, how do I replicate this payoff using my call options and put options? Once you have that answer, there are 2 ways. You can either use, or you can either price this individual call option, put option price separately. If it's buy, add it. If it's sell, subtract it, and then accordingly get the strategy level payoff. The second way is, you forget about replication using options. You use your first principles using a truncated log normal distribution in order to get the price. We did a few questions wherein you all now have the Excel with you all to play around, wherein if I have the payoff, how do I use a combination of call option, put option? If I have a word problem, and if I want to calculate it using call option and put option, we figured out a way in order to get that particular strike price. This was that kind of question wherein I need to put a floor and a cap. The next question was using my first principles. How do I calculate the price of the derivative using truncated log normal distribution? So this was the type 2 kind of questions. We'll today complete type 3 and type 4 kind of questions that we have. Type 3 is...
So just one second.
Yeah.
For that last question, I was getting to 16,380 something.
That's right. The reason being that even if you make a small rounding of difference over here, it's going to have an impact because it's multiplied by 10,000 and 5,000. So ideally, when you say you're getting 16.38, my answer is essentially 0.16365. Your answer is 0.1638, which I know is fairly close. It's because of this multiplication with 10,000, 5,000 is that the difference getting amplified. So 16,300, anything is fine. Cool. Now let's start with type 3 questions. Let me just paste a snapshot.
In derivatives, if you are losing lakhs of rupees, then 1,000 rupees doesn't matter at all.
Yeah, I mean for an institution, yeah. Let me just paste a screenshot. So now what is type 3 kind of questions really? One thing, I don't know if I have told this in your batch or not. But if anytime you have to refer to options, if anytime you want to make your concepts of options clear, or going in the industry, you want to create any valuation model, look at any valuation model. I don't know if it's already uploaded on the LMS or not. There is a book called as John C. Hull. This is one of the book, and the other book is called as Espin Gardner. So these are the 2 books that you can refer. These 2 books beautifully explain. John C. Hull is entirely on options. It explains, and why am I saying this? Because in the coming week, you'll receive your projects that has an option element to it as well. So I can use John C. Espen Gardner's start to end. It explains what are those kind of options, what are the different valuation models, what are the different variants of that particular option, so on and so forth. So well written, beautifully written book. I think John C. Just passed away last week or 2-3 weeks back as well. So it's not an author who has written books in 1800s or 1700s. It's a very much practical book. All the treasury management systems. When I say treasury management systems, Bloomberg, Calypso, the systems that are used by banks and insurance companies to hold their investment portfolio, all of them actually develop their models using such reference books and research papers itself. So well-written book, beautifully written books. If any of y'all are into reading, if any of y'all are learners who actually learn better through books and relative to Google, these are the 2 books that you can actually refer for any kind of option. Now, coming to the type 3 kind of questions that we have. Type 3, if you'll remember, we've done an entire chapter on Greeks, delta, gamma, theta, vega, rho. We understood what these options are. We understood what are the ratios, dc by dst, dc by dt, d square c by dst square. What are the ratios of these kind of Greeks? In this particular chapter, in this particular kind of question, type 3, you will be actually asked to calculate the value of Greeks. So I know using first principles delta is dc by dst, but every time I'm not going to go on differentiating my call option price equation with respect to st. I need a closed form formula. I need an equation for me to equip to calculate the value of the Greek, corresponding Greek. So similarly, you have the formula for Black-Scholes equation. In the same way, for all the Greeks, delta, gamma, theta, vega, rho, under call option, under put option, all of these are for dividend paying underlying. What is that formula? What is that equation from which you can calculate the value of Greek is what is there in this particular table. All of this are for dividend paying. If you have been asked for a non-dividend paying, it's just that the value of Q is going to be 0. Because for a non-dividend paying stock or a non-dividend paying underlying, the dividend yield is nothing but 0. So the value of Q is 0. Wherever you see capital N, that is nothing but CDF. It's your capital phi only that we've been doing. Wherever you see N dash, it's nothing but the PDF. It's your small phi, PDF or standard normal distribution. You can be asked 2 kind of questions. One is to actually derive this particular equation. That's the first kind of question. The second kind of question is, I'll give you all the values similar to type 1. You will have all the values. You will be asked to calculate either the value of the Greek or some unknown parameter of the equation. That's the second kind of question that can come in. Irrespective of whatever type, you will be given the equation of the Greek in the question itself. You will not have to remember, you will not have to mug up the equations. Equations of this Greek will be given to you in the question, except for delta. Why? Because delta is actually very straightforward to remember as well. So delta may or may not be given, but if any other Greek has been asked, the equation will be given to you in the question. All right. If you want, just note these equations down as a summary table. What I'll do is, we'll do it for one Greek. We'll derive delta for a call option. What I'll also do is, I'll send you all a PDF, which it's like a 30-page PDF if I'm not wrong, but it has the derivation for non-dividend paying, dividend paying, all of the Greeks for call and put. So you can refer to that PDF if you have to refer to any derivation of any particular Greek. I'll send that PDF right across. And then just copy this. Right, it's a 29 page of this. I'll send it on the unofficial that we have for FA. That. So that's a good PDF for getting the concepts of Greeks. Let me know once you all have done copying. We'll start with the derivation for one of them. In your batch, you have majority outstation, right? Ria is, I think, East, Ashok, Middle East. Bhavani, you're from South, if I'm not wrong. Anushka, you're from?
I am from Maharashtra, Vijayawada.
Which place?
Jalgaon.
Jalgaon.
We all are from different parts of the world.
Abdul Rahman is from there. I don't know where Tom is from. Tom, you are from?
Tom is from Kerala.
Oh. I actually don't mind visiting all the places. I haven't traveled India that.
Kerala state's name changed now to Kerala.
Kerala. West Bengal is going to change to Bangla.
Huh?
West Bengal proposition has come to change it to Bangla.
Bangla.
Yeah.
Oh.
I think I may actually come in November. We can catch up a shoot if I end up coming.
November? When?
Sorry, October. Because November is Diwali. I want to come back to India before Diwali. So I may probably come somewhere around 15-20 October.
Sure. We'll catch up that time. If I'm not coming to Mumbai for exams, then we can meet.
Yeah. This, remember, for theta, this 2 root t is just for the first term. So it's minus S0 phi of t1 sigma e raised to minus qt divided by 2 root t plus q S0 capital phi d1 e raised to minus qt minus rk into e raised to minus rt phi d2. That's how the equation of theta looks.
PDF, but you have sent it to know. This thing is taken from the hall, no?
This is taken from the HUD. Yeah.
It's available in the Amazon, no? The book is available, no?
It's available on
There's a heading is derivatives, huh?
Greeks.
Greeks, only for Greeks, that book is for.
No, the book is for John Searle is for options. Major.
No, the name of the book is Derivatives of
Searle.
Greeks.
No, it's John C. Hullum.
No, that name of the book, it's an author only, no?
Let me see. John Searle is the author. The book, let me see the name of the book. I think it will be high chances uploaded on your LMS also.
Yes, it is uploaded.
Does not. Tom, you have it on the LMS as well, but let me see. It's called as options, futures, and other derivatives. If we complete the lecture early as well today, I'll just give you all a brief on the project that you're going to get. It'll come to you this week. We just want to Feb seemed too early, so we were just waiting for 1 week because it's that much. So you'll come get the project this week. We can just discuss what the project is so that you all can start the day, sir. And then if you all have queries, you can reach out anytime. Because today is going to be the last, I actually feel happy whenever I say this. Because at the start of the subject, I told you all that from Brownian, ensure you're set right up to Black-Scholes. This is the chapter where that ends. Brownian, Ito's, Black-Scholes, all that continuation is where it ends. From this, now the next 2 chapters that we have is fairly independent. There's not much of a dependency on the previous chapters that we had. And these are now relatively shorter chapters. If you were to study independently as well, these are chapters that will complete in 2 days. So the significant chapters have been completed till today. Let me know once that.
So
Follow.
this D1 and D2, what we have here is the one we derived.
Same. Wherever under Black-Scholes or under options you see D1 and D2, everywhere it means the D1, D2 that we that's a globally recognized notation. Hence, it's not replaceable to any other equation. Just put the heading delta for a non-dividend paying call. We'll derive that equation.
Sir, we solve for PT approach. That equation is for call and put. Both are same.
Yeah. It's
Okay.
the same for both.
So, sir, where are we going to use that approach?
The PD equation?
Yeah.
Nowhere.
So, like, we just need to know the derivation. How to?
Yeah. So it's just from a derivation point of view, and it's for you to recognize that it wasn't the Black-Scholes, the option pricing formula that they directly came to. They actually started with the partial differential equation approach, and they realized that it's not going to be feasible to use that in reality. Hence, they started with the expectation-based pricing, which is your the first derivation that we done. But apart from the derivation, the only probable way where it can come is I can give you all the values, or if I actually want to build up an equation, I'll give you to calculate Greeks. Once you get the value of all the Greeks, you will have to substitute it in that equation and then get the value of option. Or I can give you the value of the Greeks and ask you to calculate the value of the option. Sometimes I feel good I'm not the setter.
Sorry.
Sometimes I feel good for all that I'm not the setter, considering the questions that actually come. But yeah, short answer, they can, it's either just majorly from a derivation perspective, or they can give you all the known values, keep one parameter unknown, you'll have to calculate that one unknown parameter. Done, everyone?
Yes, sir.
Yeah.
Let's start with the derivation. So as I said, let me derive for internals you there. So your internals are also not done. Oh, your internals are done.
No, no,
Oh,
I
yeah,
internal.
internals are not done.
Yes.
Yeah, internals I am the one who sets. But the internals are MCQs. It's not like you cannot solve it. You have one answer correct, you just need a 25% probability. And a
But
confidence
it
level.
will affect the total marks.
Yeah, I mean it gets scaled up, scaled down, and then it adds up to your total internals. Cool. So let me derive for one of the option that we have. We'll derive it for Greek. As I said, for all other derivations that you have the PDF that I've just shared across with you. In case you have doubts in any of the derivation, we can then discuss that separate derivation. So let's derive it for delta. We'll derive the Greek delta of a non-dividend paying call option. So let's derive the equation for delta for a non-dividend paying call option. I know the answer based on the above chart that we drew. I know it's non-dividend paying, so sorry, e raised to minus qt will go away. I know the answer should be what? ND1. I know this is what I should get the answer as. Let's derive how to get that particular answer. Now, as a starting point, whenever you don't know as a starting point, you start right from the first principles. I know for the call option, what information do I have till now? I know that C0 is actually equal to S0 phi D1 minus K into e raised to minus RT phi D2. This is what I know. If I don't know anything, at least this is something that I know, where the equation of D1 is actually equal to log of S0 by K plus, if I'm not wrong, it's R plus sigma square by 2T. Yep. R plus sigma square by 2T by sigma root T. This is the equation that we know. This is something that I already know. Now, first principles tells me what? Delta is nothing but dc by dst. This is something that I know, that delta through definition is nothing but change in the price of the option with respect to the underlying price. I have my equation of call option price. Let's start. Let's differentiate, because I'm doing everything from first principles. Differentiating C with respect to S. Therefore, can I say dc by ds is equal to, I'll have to do a UV rule over here. Why UV rule? Because this is phi d1. It's not like phi d1 is independent of S. There is an S sitting inside d1 as well. Therefore, I can't simply write this as phi d1 because it will have to have a UV rule. Phi d1 is not constant. Therefore, I do a, when I say UV rule, I'm not sure if the terminology is familiar. UV rule is basically the product rule of derivation or differentiation. Sorry. So I know U, derivative of V plus V. I'll just write as well. We'll do it granularly. Derivative of U. This accounted for my first term. In the second term, now I know K into e raised to minus RT is independent of S. That's the strike price. Therefore, I don't have a product rule, but inside D2 there is S. So I'll have to write this as minus K into e raised to minus RT D by ds of phi of D2. Fair enough. Any doubts in this equation? All right. Now, one question to you all. Whenever I write, let's say I have a chain rule equation. If I write d by dx of e of x square, what's the answer for this?
2x e raised to x squared.
E raised to x
2x
square
e
into
raised to
2x.
x squared.
Perfect, because e raised to x is e raised to x, and then I'll differentiate x square with respect to 2x. This is what you know on the surface. Actually, do you know how the differentiation happens? D by dx ex square is actually nothing but d by dx square e of x square into d by dx of x square. This is how the differentiation actually happens. Because when you say e raised to x, can I say I'm essentially differentiating with respect to x square over here? When you say e raised to x is e raised to x and you write e raised to x square as e raised to x square, you are essentially differentiating with respect to x square. And then once you differentiate this, you are then differentiating your original equation with respect to x. Therefore, it's a two-step chain rule that actually happens. First, you differentiate with respect to that modified equation, and then you differentiate the modified equation itself. Fair enough? In a similar way, can I say in my equation, dc by ds S0, this can I write it as d by dd1 phi of d1 into d by ds d1. What I did, I know phi d1, this is essentially like a chain rule, because first I have a modified equation and then inside that equation there is s sitting. So I'm first differentiating with respect to d1, the phi d1. And then once I do this, I need to apply chain rule. So then I'm differentiating s with respect to that modified equation with respect to d1. Comfortable, everyone? Now, as part of the second equation, I know d by ds of s is 1. So phi d1 will come as this minus k into e raised to minus rt. Similarly, over here, can I say it's d by dd2 phi of d2 and then chain rule on d2. So I'll have to do d by ds of d2. Fair enough? Phi d2 is my modified equation, so I'm first differentiating with respect to d2. And then d2 is what has s in it, so I'm differentiating d2 with respect to s. Everyone understood this part? This was the only major complicated part of the differentiation or the derivation. Now it's plain vanilla. So dc by ds. Can I write S0 d by d1, phi of d1, can I say is PDF of d1? Derivative of a CDF, d by dx, CDF of x is actually PDF of x. Therefore, I write this CDF as PDF over here. Into, can I say d by ds? I know the equation of d1 is ln s0 by k plus r plus sigma square by 2t divided by sigma root t. I just substituted the equation of d1 over here plus phi of d1 minus k into e raised to minus rt. Similarly, can I write this as PDF of d2 into d by ds? I know d2 is what? d1 minus sigma root t. This we've established using when we are doing the Black-Scholes derivation. Any doubts over here? Anyone? All right. So now what I'll do is I'll solve the derivative of this equation separately, because otherwise things are going to become quite huge. I'll treat this as one term. I'll treat this as the second term, and I'll treat this as the third term. I'll solve all three terms separately and then bring all three terms together as the same equation. Let me just give a minute. Let me plug my charger in. Yeah. So let's solve the first part first. So I have the first equation. So first part. Do you actually know what is going to happen? You know what you need the answer as. ND1, which is phi D1. So if you see in this entire equation, phi D1 is only over here. So essentially this entire term and this entire term is going to get cancelled out going forward. For that one single thing, we have to derive the entire thing. So let's start with the first part first. Now, S0 PDF of D1 into d by ds log of S0 by k plus r plus sigma square by 2t divided by sigma root t. This is the equation. Let's start solving this. So S0 phi d1. I know this can ideally be written as log of S0 by k divided by, should I write sigma root t outside because that is independent of s? I know sigma root t is not going to get hampered because of the derivative because it doesn't have s in it. So I write 1 by sigma root t outside of it. Now, if I split all of this, log of S0 by k plus r plus sigma square by 2t. I know r plus sigma square by 2t doesn't have any s related term. Therefore, this will become 0. Log of S0 by k. I know as part of my equation. Can I write? Let me actually write. Okay, let me tell it this way itself. This doesn't have S0 term. Therefore, this became 0. This can I write as ln S0 minus ln k? Ln k is again a constant. Doesn't have any s related term. So even that will go off. What am I left? Log of s. Log of x is what? 1 by x. Differentiation of log of x is 1 by x. Therefore, can I write this as S0 phi d1 into 1 upon sigma root t into, or rather, let me write this as 1 upon S0 sigma root t. The differentiation of d by ds of d1, the answer came out to 1 by S0 sigma root t. Fair enough. S0 will get cancelled. What am I left with? Phi of d1 divided by sigma root t. I know I cannot solve this any further. Just the only thing I can probably do is, I know PDF of a standard normal distribution, phi of x. If you go to your table books, this is actually equal to 1 upon root 2 pi e raised to minus x square by 2. If I'm not wrong. Am I wrong? No, that's the one. This is the equation for a PDF of standard normal distribution. It's there in a table book. Phi of x is 1 by root 2 pi into e raised to minus x square by 2. Can I say on similar lines, the equation of this will become 1 upon root 2 pi into e raised to minus. For me, x is actually t1 square by 2, the whole upon sigma root t. Fair enough. Any questions till here? All right, let's move further. Second part, I have nothing to solve for. I'll keep phi d1 as it is. Let's solve the third part now. So third part has what? So let's solve the third part. The equation of third part is k into e raised to minus rt phi of d2. So this became the PDF above when we solved. Phi of d2 into d by ds of d2 or d1 minus sigma root t. That was the equation. K into e raised to minus rt phi of d2 d by ds of d1 minus sigma root t. Now, if I solve this, k into e raised to minus rt phi of d2 d by ds of d1, can I say is 1 by s0 sigma root t? In my previous question, I had differentiated d by ds of d1. When I solved this, I got the answer as 1 upon s0 sigma root t. Therefore, can I say d by ds of d1 is actually equal to 1 upon s0 sigma root t? Any confusion here? I'm just, instead of solving it all over again, I'm just using the result where I've already solved it. And I know sigma root t doesn't have s component in it, so that will become 0. Therefore, can I say this equation is actually k into e raised to minus rt into, I know phi of d2, so this will become 1 upon root 2 pi e raised to minus d2 square by 2 into 1 upon s0 sigma root t. I've just used the equation of PDF of standard normal distribution. Now I know there's d2 over here. I know I can solve d2 at least. Let's simplify where I can into 1 upon root 2 pi. Can I write d2 as e raised to minus d1 minus sigma root t the whole square divided by 2 into 1 upon s0 sigma root t? I've written d2 as d1 minus sigma root t because that is something that I already know. Now, can I write this as k into e raised to minus rt divided by root 2 pi into e raised to minus a square? We actually write it so that we check. A square minus 2ab plus a minus b the whole square is a square minus 2ab plus b square, which will become sigma square t, the whole divided by 2 into 1 by s0 sigma root t. Fair enough. I've just opened a minus b the whole square as a square minus 2ab plus b square. Comfortable? Now can I write this as k into e raised to minus rt by root 2 pi e raised to minus d1. Can I write this as minus d1 square by 2 plus d1 sigma root t minus sigma square t by 2. I've just opened minus and I've divided 2 across. So minus plus minus into 1 upon s0 sigma root t. Any confusion over here? Now I know the equation of d1 is what? Log of s0 by k plus r plus sigma square by 2t upon sigma root t. If I shift sigma root t on the LHS, d1 sigma root t will be equal to what? Log of s0 by k plus r plus sigma square by 2t. I have a d1 sigma root t over here. Can I write this as k into e raised to minus rt by root 2 pi into e raised to minus d1 square by 2 plus, can I write this as log of s0 by k plus r plus sigma square by 2t minus sigma square t by 2. As discussed, d1 sigma root t is just going to be the numerator part of d1, which is what? Log of s0 by k plus r plus sigma square by 2t. Comfortable? Everyone with me? all right, into what is left is 1 upon S0 sigma root T. Now, if you see closely over here, sigma squared 2 by T minus sigma squared T by 2 will get cancelled. E raised to RT will get subtracted with e raised to minus RT. What else will I have? Let's solve this one step further. K by root 2 pi e raised to minus d1 square by 2. Can I say this will become S0 by K in down? Because e raised to log of S0 by K is S0 by K. Fair enough. E raised to log of X is X itself. So e raised to log of S0 by K is S0 by K. And everything else had gotten cancelled out into 1 upon S0 sigma root T. Can I say S0 S0 will get cancelled? K will get cancelled. What am I left with? 1 upon root 2 pi e raised to minus d1 square by 2 into 1 upon sigma root T. Any questions till here? Now, if you see the third part and if you see the first part, they're exactly the same. 1 upon root 2 pi e raised to minus d1 square by 2 upon sigma root T. 1 upon root 2 pi e raised to minus d1 square upon sigma root T. And if you actually see the equation, first part is positive, third part is negative. So both of them will actually get cancelled out, with you remaining only with the second part, which is phi of d1. All right, let's write it formally as well. Combining all three parts, can I say delta for a call option is equal to, first I write the first part, 1 upon root 2 pi e raised to minus d1 square by 2 into 1 upon sigma root T. I write my second part, which was phi of d1. I write my third part, which is 1 upon root 2 pi e raised to minus d1 square by 2 into 1 upon sigma root T. If you see now closely, this is positive, this is negative. This entire term will get cancelled, leaving you with only delta of a call option is equal to phi of d1. Fair enough. And this is ideally what I knew I had to get. Because for a non-dividend paying, e raised to minus qt will be equal to 0. ND1 will be your answer, which is nothing but phi of d1. Comfortable? So the only thing that actually came out new was the chain rule. I mean, that also something you knew but didn't click, which was nothing but the chain rule. Otherwise, it's normal algebra and the equations that you already know. In the same way, all the derivations of all the Greeks, dividend paying, non-dividend paying, are there in that PDF book, including the one that we derived. Cool. You can copy this down. Yeah. Let me know if while copying you all have any questions.
Sir, I had one question. While differentiating the first line where it is in the call option, so why is it not like two terms? There are only one term, right? Like k e raised to minus rt.
Because you are asking why not product rule in the second term.
Yeah.
Because K is independent of S. So that will come out. There's only one term phi of D2. In the first term, I had S0 phi D1. So S0 is a term dependent on S and phi D1 is a term dependent on S. Hence, I had to do a product rule there. Understood? If I'm done with this equation in blue, then I'll stop. This is extra. Understood. I think the network as well.
Can you
Yeah. Hold on. ठीक है हम लोग को भी Let me know once I'm done. We can actually derive the equation of gamma as well. It's just one more step after this. Let me know once everyone is done till here. Let's do gamma of call also. It's just one additional step. That also gets completed.
Will we do differentiation again?
Exactly. You'll differentiate this again. You know it's phi d1, so you'll apply chain rule like the previous one. D by d1, d by dd1 of phi d1 into d by ds of d1. D by dd1 of phi d1 is what? PDF of d1 into d by ds of d1. You already know is 1 upon s0 sigma root t. That's the equation of gamma. Everyone done till the black part? All right. So now after this, you know, if you differentiate, right. All right. If you differentiate for a better form, if I differentiate this again, because I know gamma is nothing but derivative of delta with respect to spot price with respect to underlying asset price. So I know the equation will become d by delta upon ds is equal to, I'll apply chain rule over here. So d by dt1 of phi of d1 into d by ds of d1. The same way that we did it in delta. I know this is equal to what? CDF will become PDF into d by ds of d1 we already derived. If you remember this part, d by ds of d1 was what? 1 upon s0 sigma root t. So if I write that same equation again into 1 upon s0 sigma root t. Now if you see your chart, the formulas that you type, for a non-dividend paying e raised to minus qt will go away. What do you get the answer? Phi of d1, PDF of d1 divided by s0 sigma root t. That is what even we got. That is the derivation for your gamma. So if they ask you to derive gamma and ask you to assume the value of delta to be true, you just need to do this step. If they ask you to derive gamma and they don't tell you like assume the value of delta, or they don't give you in the question assume the value of delta to be phi of d1, you'll have to do the entire derivation. Obviously that will be for a 5 marker, 6 marker question. If only this part is asked, it may be a 2-marker question. All right. Therefore, gamma of call is phi of D1 upon S0 sigma root T. Now you can copy this down. We are done with type 3. We'll go to type 4.
Sir, so we don't have like numericals in
In numericals, they can just give you, like, now you know how to calculate D1, you know how to calculate phi D1, they can ask you to calculate delta. So that's the kind of question that can come in. They can give you one unknown, all known parameters, one unknown parameter. Or the other way around. If I give you the value of delta and if I ask you the strike rate, then you'll have to do the trial and error approach over here. Or you can actually just invert phi of over there as phi of inverse. Find that in table book and get the value of unknown. So you don't even need to do the iterative method over here. Take a minute, let me know once everyone is done. We'll go to type 4.
So how do we use phi inverse from
So if you go in your table book, one table is let me show. Tables for standard one. So phi inverse also you'll ideally have to interpolate only probabilities for pi square for standard norm. Yeah. So under this phi inverse, what you'll have to do is, let me present tables. So whenever you had to calculate x, phi of x, you look at your value of x and get this particular corresponding value of this. Now, when you need phi inverse of x, you ideally need, or phi inverse some probability value, you ideally need, or you will know this particular value, you need to calculate the bold values. So let's say if I give you the answer of delta as 0.6, you know the value of D1 is somewhere between 0.25 and 0.26. So you'll interpolate not for this, but for the bold values. That is how you'll calculate phi of inverse. So if I tell you the value of delta is, for the option is 0.6, I'll give you everything, ask you to calculate strike price. You know phi inverse 0.6 is going to be somewhere between 0.25 and 0.26. You can interpolate and get the value of the exact answer. Let's say the answer comes out to be 0.255. That becomes 0.255 is equal to D1. Now D1 you have everything known, only strike is unknown. You can get the value of strike. That is how you calculate the phi inverse. So under phi of x, you interpolate on this, you know everything of bold. But in phi inverse, you know everything of this, you need to interpolate for the bold values. Cool. So ideally, when you calculate phi of x, you know x, x1, x2. You know y1, y2, you need to calculate y. Under phi inverse, you know y, y1, y2, x1, x2, you need to calculate the value of x. That's how you calculate the phi inverse. Only the axis changes, nothing else. We'll come back to this. Any questions, please? Yeah, Abdullah.
Yes, please. Can you explain this differentiation again, please?
So let me, if I tell you, let's say x is 0.25, or rather I tell you D1 is 0.25. The way you will calculate your D1 is 0.25, you need to calculate delta. You know delta of a call option is phi of D1, which is phi of 0.25. The way you will calculate this is, you will directly go in your table books.
No, sir. I'm asking about the differentiation of this delta.
For the differentiation. So when you say phi of, say phi of 0.25, your answer is going to be 0.59871. Fair enough?
No, sir. No, sir. Go back to one note.
What? Oh, you're saying the gamma derivation.
Yes, exactly.
Okay. So you know d delta of by ds. I know delta is phi of d1. If I go back to my chain rule, phi of d1 was what? D by d1, phi of d1 into d by ds of d1.
Yes.
So what I do is, instead of phi of d1, I write this as my derivative. Now I know d by d1, CDF of d1 is PDF of d1.
Yeah.
And d by ds of d1, if you see the previous one, d by ds of d1, we calculated as 1 by s0 sigma root t.
Yes, sir.
So that is what I substitute over there. And then I got my answer for my gamma.
Okay.
Understood?
Yes, sir.
Cool. Let me erase this. Alright. Let's start with type 4. I think it sounds good time to erase this. Just put the title. So let's start with the last type that we have, which is type 4. I call it as look back option, is not actually a look back option type, but let's see what kind of question it brings. Let me put a question. We'll start with a question. We'll look a question and we'll understand this. Now, when if this entire type, so it's a rare case, first of all, it's rarely asked in questions. Even I might have asked it like only a handful number of times in these past few years. Therefore, type 4 kind of questions are very rarely being asked in any paper. But given that, let me show you this. So if you go on page 38 of your table books, there is an equation that is mentioned over there. Let me paste it here as well. This is on page 38 of your table books. So this entire type of type 4 is built upon, is related, has relations with this particular equations, wherein what this equation tells you is Ps is a standard Brownian motion. S is nothing but time. So it tells you that probability that the maximum value of this Bs plus mu s is greater than y is actually equal to this particular equation. Where this equation came from, why this equation that we don't have in scope. But this is an equation that upon which this particular entire type of sum is built. I know it's not very clear now. Hence, let's do a sum and then things will become clear. Let me just put the question down over here. Just down. Let's see the question and then it'll become clear. So the question that we'll do is April 2030, question 9. If you all want, just note this equation down. That is what we'll use. Just note this equation down and then we'll start. Just remember Bs is standard Brownian motion. S is nothing but time. Let's solve that one question and it'll become clear as to where this equation is. Done? This is again your CDF of standard normal distribution. Let's start that question now. As I said, the question is April 2013, question 9. Let's see first what that question is asking. We'll solve it and then you'll have a look. In a Black-Scholes market, we consider a special option with strike K and expiry in 2 years. So I know it's a special option. It's not a plain vanilla option, wherein the time to maturity is 2 years. On an underlying non-dividend bearing stock with price process ST. All right, so they're saying there's an underlying asset price which is ST. The strike price of the option is K, and the time to maturity is 2 years. Its payoff at maturity is 100 into max of S2 by S1 minus 1 comma 0. So what they are saying is at time 2, at maturity, the holder of the option will receive 100 into maximum of S2 by S1 minus 1 comma 0. Where what is S2 and S1? It is the underlying asset price at time 2. It is the underlying asset price at time 1. So they are breaking the entire 2 years into 2 time steps. 1 year and the next 1 year. Fair enough? Where the spot price at the end of 1 year is called as S1. The stock price at the end of the second year is called as S2. And you will receive the payoff 100 of max of S2 by S1 minus 1 comma 0. If and only if the stock price has not exceeded by time 1. That means, can I say, they are saying if the maximum value of the stock price, if the maximum value of the stock price between 0 and 1, the maximum value of S1 is actually less than 2, is what they are saying. Let me write this as ST. Again, what did I write? They are saying you will get this payoff if the stock price is not exceeded by time 1. That means, can I say they are saying that the maximum value of the underlying asset price between time 0 and 1 should ideally be less than 2. Because if it is greater than 2, then you don't get this payoff. Because the stock price has exceeded 2 by time 1. That is when you will not get the payoff. That is why this condition has to be true. What this condition states again, that the maximum value of the underlying asset price where the time is between 0 and 1 should ideally be less than 2. So it's ideally saying your OHLC, open, high, low, close data that you see in financial markets. They are saying that the high has never exceeded $2 between time 0 and 1. Fair enough? With me? All right. Now, the volatility of the stock is 25% per annum. Continuously compounded risk-free rate is 3% per annum. The initial stock price is $1. Fair enough? Everyone understood what is given in the question? All right. Can I actually break this down into 2 things? There is actually one cryptic, one not mysterious, one thing that they actually have hidden in the equation, which 99% of the students don't get. Can I say, if I actually break this down into 2 steps, if I solve this payoff equation, 100 into max of S2 by S1 minus 1. Can I write this as S2 minus S1 by S1 comma 0? There is actually a second condition for this payoff to be true. If S2 is greater than S1. Why so? Because if S2 is less than S1, the stock price at time 2, if it is less than the stock price at time 1, this will go negative. Therefore, this term will go negative. In that scenario, you are going to get 0 rupees. Therefore, you getting this payoff is not just conditioned on one thing. It's actually conditioned on 2 things. Fair enough? So the payoff that you are actually receiving, 100 into max of S2 by S1 minus 1 comma 0 is actually based on 2 things. One condition is that maximum value of the underlying asset between time 0 and 1 should not be greater than 2. This is the first condition. The other condition is S2 has to be greater than S1. Fair enough? Everyone with me till here? Anushka, you were disconnected. I was saying the second condition is, I know S2 by S1 minus 1. Can I write this as S2 minus S1 by S1? The other condition, you were there in this first condition. The other condition, if S2 is less than S1, can I say this will go negative? If S2 is less than S1, this will go negative. Therefore, you are going to get 0 rupees as the payoff. Therefore, it's not just one condition. There are actually two conditions on which you will get the payoff. The first condition is that your maximum value of your underlying asset price between 0 and 1 has to be less than 2. And the other condition is that S2 has to be greater than S1. Because if this is not the case, then your payoff is going to go negative, which is then flow to 0. Hence, you are going to get nothing. Fair enough? Now, can I say that this is a condition from time 0 to 1? You are checking this condition between time 0 to 1. And this is a condition that you are checking between 1 and 2. If I was to break my entire timeline, 0 to 2 years, the first condition is actually applicable between time 0 and 1. It has nothing to do between time 1 and 2. But the next condition, S2 has to be greater than S1, is got to do with 1 and 2 as the time period. Now, can I say the... Yeah, Anushka, go ahead.
Sir, how you decide that first is only applicable for 0 and 1 and second is for 1 and 2?
Cool. What are they saying? The underlying asset price does not exceed 2 rupees, is only between 0 and 1. They have said that this has to be by time 1. Therefore, I don't care if between 1 and 2 if it exceeds 2. By time 1, it doesn't have to exceed 2, is what they are saying. Therefore, I know this is between 0 and 1. And the other thing where I'm saying S2 has to be greater than S1, S1 has already occurred. The condition is that S2 has to be greater than S1. Therefore, the movement will be between 1 and 2. That is how the next condition. Fair enough? Now, can I say price of the option? Again, I don't know. Let's say I don't know anything, but I still know using first principles. What is the price of an option? Payoff into probability into PV factor. This is what we know through first principles. Can I say the payoff is what? They have already given to me 100 into max of S2 by S1 minus 1, 0 into, there will be actually two probabilities. Probability that your maximum value of ST, where T is between 0 and 1, is less than 2. And the second probability will be S2 greater than S1. So payoff into probability, and it's a 2-time step. Therefore, e raised to minus 2r becomes your PV factor. R is per annum, T is 2, so e raised to minus 2r. Everyone with me? This is the part which IFO does, which if you look from the IFO solution, it's not at all clear. Hence, if you all have understood this, we've framed up as to what the question is, what the price is going to be. Now, what they've done is, in 3 separate subparts, they're asking you to calculate each of these separately. All right, we'll solve and then we'll draw parallels with the question. We'll solve the entire question as one single question itself. Now, can I say between time 0 and 1, the price of the derivative is actually going to be payoff into probability. What is the probability applicable between 0 and 1? I know it is probability of max of ST, where T is between 0 and 1 less than 2. Into it's only 1-time step, so e raised to minus r. This is the price of the derivative between time 0 and 1. Between time 1 and 2, can I say the price of the derivative is payoff into probability into again PV factor. This is the price of the derivative between time 1 and 2. First sub-question, what they are telling you is calculate the probability value of this. Calculate the probability that max of 0 T1 S2 is less than 2. That is the first part that they are ideally asking you to calculate. All right. Everyone understood till this part over here? How did I come with this 2 separate equation? Why this equation holds true? Alright. Now what they're asking is calculate this probability. So let's try to calculate this probability. So probability that max of 0 to 1 ST is less than 2. Now I have never came across an approach through which I can actually calculate the probability of a maximum value of ST being less than or greater than. That is something that I haven't come through. This is the part which is specific to type 4, wherein you can calculate the probability that over a time interval, the value of a random variable is actually highest or lowest. That is what you can calculate through this type 4. But I know in my equation that I've seen, it is probability of max of standard Brownian motion plus something into time. But I know here it's not of this particular form. Here it's simply ST. So you'll have to work around to bring it in this particular form for you to able to use this particular equation. Now I know if I have to bring into picture standard Brownian motion, there is only one equation that I know. ST is equal to S0 into e raised to r minus sigma square by 2t plus sigma square t plus sigma bt. This is the only equation that I know which brings about ST and it brings about standard Brownian motion. This is the equation that I know. Therefore, what I'll have to, let me use small t. What you will have to try to do is frame an equation in such a way that you get standard Brownian motion plus something into time. Because that is what the form I want it in. Bs plus mu s. Bs is standard Brownian motion plus something into s, which is into time period. So we'll have to work around to bring this equation in this particular form. So first, I know I don't need this exponential over here. So let's take log. First S0, they've given me the value in the question as $1. Let's get rid of S0. So I know ST will be equal to e raised to r minus sigma square by 2t plus sigma bt. Now I know I don't need exponential. I don't have any exponential over here. Let's get rid of the exponential. Log of ST is equal to r minus sigma square by 2t plus sigma bt. Now you see, I got standard Brownian motion plus something into time. But I don't need this sigma over here because standard Brownian motion has to be standard Brownian motion. Let's get rid of that sigma also. So ln ST by sigma is equal to r minus sigma square by 2 divided by sigma into time plus bt. I divided sigma throughout. Now you see, Bs plus something into time. I got in this particular form. Therefore, can I write probability that maximum of 0t1 st is less than 2? To bring it in this form, I'll have to first bring it in this form. Therefore, can I say probability that max of 0t1 log of st by sigma is less than, if I do it on the LHS, I'll have to do it on the RHS. So log of 2 by sigma. Now I know ln st by sigma is what? R minus sigma square by 2t upon sigma t plus bt. Can I write this as probability of max of 0t1 pt plus r minus sigma square by 2 the whole by sigma t less than ln 2 by sigma? With me, everyone? Now you see, if you see the equation that you've noted, I won't scroll it, you'll have it noted in your book. Maximum of Bs plus mu into S. Our equation is greater than, it's not less than. If you see the equation that we have, it's ideally a greater than equation, but I have a less than equation over here. Easy, I'll do 1 minus, which will give me greater than sign over there. So max of 0t1 pt plus r minus sigma square by 2 divided by sigma into t greater than ln 2 by sigma. Fair enough. Less than, I wrote it as 1 minus greater than. Now I can use this. I know how to solve this equation. How do I know this? I have the equation in my table book, page 38. Let's try to solve this equation. What does the equation tell you? The answer of this equation is therefore 1 minus. If you now draw, let me bring that equation down also. Let me bring this equation down so that I don't have to scroll at the time out. I paste it over here. Now, if you draw parallels, 1 minus phi of minus y. What is y? Y is nothing but this value. For me, y is nothing but this particular value. Therefore, phi of. Should we actually calculate y, mu, all of that separately and then substitute? Will become easier to write it as well. For me, y is what? ln 2 by sigma. Mu is what? R minus sigma square by 2 upon sigma. So can I say mu is R minus sigma square by 2 divided by sigma? Do I need anything else? I know time period for me is 1 year because I know 0 t1. So this is the time value t which they are using, which I know is 1 year. Do I need anything else? I don't need anything else. Can you tell me with the values? You know R is 3%, sigma is 25%. Can you tell me the value of y and mu? R is 3%, sigma is 25%.
Y is 2.772
2.77.
25
Okay.
882.
881.
No, 722.
2.77258872.
8872. Okay, even if we stop till 2.77259, it's 5 decimals.
Minus 0.005.
Minus 0.005. I think they're correct. Okay. Now, any questions till here? Now I know if I have to solve this equation, the answer is what? 1 minus phi of minus y. I know y value is 2.77259. So 2.77259 plus mu t. Mu for me is minus 0.005. So minus 0.005. Time is nothing but 1. The whole divided by root t, which is root 1. Plus e raised to 2 mu y. I know e raised to 2, the value of mu is minus 0.005. The value of y is minus 2.77259. So e raised to 2 mu y into,
Y is not minus, sir.
sorry, y is not
Y is-
minus, y. So this becomes positive. Into phi of, the only difference is minus y minus mu t. So can I say this becomes minus y minus mu t, minus minus plus 0.005 into 1 divided by root t, which is root 1. Everyone understood this part? I've just applied my equation. Now, 1 minus, can someone tell me the answer for, this is fine, minus 2.77259 minus 0.005 will be 0.05.
minus 2.77759.
7779. Yeah. So plus, can someone tell me this answer? So 0.5 of minus plus minus 0.005. 9 as it is.
0.972654.
Sorry,
0.972654.
2.972654.
55.
55. Cool. And this will become minus 0.05. So 5. And this will become 7. This will become 6, 7. Hopefully, I'm right. Now, this is what you'll have to calculate from tables. This is what you'll have to calculate from tables. Once you get all the values, you will get the value of the probability. Cool. Copy till here. We'll then do the next steps. Again. While copying, let me know if you all have any questions. You all can actually note this down. Actually, note whatever. The question is April 2013, question 9. The total question is for 12 minutes. Let me know once you have any question. I'll just go on explaining you all what is. So first, we just wrote all the given values. After a break, yeah, we'll be done with this question in the next 10 minutes, 10-15 minutes, and then there's just a minute concept. Then we are done with the chapter. Then I can just explain you all the project and we can explain.
Sir, the project marks is count in our exemption or it is
For
only
FE, it will be counted. For FM also, it's counted. Yeah. For FE also, it will be counted. The weightage is given to you all, but yeah, the project marks are counted.
okay.
Right. So first, we just written all the given things. Then we figured that there is a hidden condition, hidden second condition as well. We figured that hidden second condition. Yeah. I mean, there are a lot of things that you need to figure out, and it's thoda lengthy to solve. Don't worry, there's one more thing coming out. Our type 1 formula will also come now.
Hopefully, this will come in 4A, 4B.
Yeah, it won't be less than that. Even if it's there, then it'll be just to calculate this probability value. That will be a 5-marker question. If the entire question comes in, it's 4A4.
So that we can skip.
Yeah, fair. Then we just wrote a summary. What is applicable, which condition from 0 to 1, which condition from 1 to 2. Then we just wrote the equation of the price of derivative through what we knew as the first principles. This is the entire price of the option between 0 to 2. Then we just wrote the equation, breaking it down into time one price, time two price. So we applied the probability of time one only in the first part. We applied the probability of time two only in the second part.
2 hour exam, it will take 1 hour for this.
1 hour we want.
Doing, we are not sure of correct words.
Right?
So the whole thing that we have done is the first probability only. That we
Is
did.
the first probability. Yes.
Okay.
Second probability is where we'll bring in our type one. So after writing it separately, as I said, we started with the calculation of the first probability, which is max of 0 to 2, 0 to t to 1, st less than 2. This looks like our equation, but we have to bring it in the form that the equation is in, ps plus something into time. So we started with bringing it in that particular form.
So how did we get this equation? ST is equals to S0 VV.
Share price process, Ito's lemma.
Yeah.
Once we got our equation in that particular form, so this part will remain constant every time. If you all have st, you know, if you need to get it in the form of the equation, this is going to be the only equation. So once you get it in that particular equation, we substituted it in order to bring it in our form. So I got the equation in that particular form. I substituted everything, brought it in. I knew my equation is greater than, but the value that I have is less than. So I took it as 1 minus and then solved the equation as per my table book. Once you are done with writing this, just try to calculate the probabilities as well.
Just one question, sir. This question, does it always come in this form or it can change?
So it may not necessarily come in this form, but you will have something like the maximum value is less than some value or the maximum value is greater than some value. In that case, you need to apply this equation.
Okay.
Just feedback once you are just done copying, calculate the value of the product. Let me know if anyone gets the answer for the problem. Nine, 4, 5, 1, 5, 3. 0.9945153. The answer looks correct. Yeah.
Sir, we need to interpolate for this or interrogate.
Yeah, you know phi of minus x is nothing but this particular value. This is equal to this particular value. This is what? 1 minus phi of x. So you'll have to calculate phi of 2.77759 by interpolating. Calculate 1 minus phi of this to get this particular answer. Then calculate 1 minus phi of 2.76759 to get this answer. And then substitute it over here. So remember the property that phi of minus x is equal to 1 minus phi of x. So you can calculate this value using this equation, calculate this value using this equation, substitute and get the answer. So if anyone facing any issues. Everyone got the answer? Take 2 minutes more if required. I continue. Done, everyone. All right. Now, what we've gotten is, Anushka, you need a minute, or should we continue? Cool. Now, what we've gotten is, we've got this probability value of max of, yeah, Anushka, you're saying something?
I said answer is 0.9945.
9945 we have it.
45161.
45161 is fine. That is because of the interpolation. That's fine. 9945 till the time you have it's correct. Cool. So now what did we get? We got this particular probability value. Now the next question is calculate the price of the derivative at time 1 and calculate the price of the derivative at time 0. These are the two questions. I'll repeat. Calculate the price of the derivative at time 1. Calculate the price of the derivative at time 0. I know if I'm standing at time 1, price of the derivative is nothing but the discounted present value of future cash flows. I know at time 1, the price of the derivative will be equal to this equation. Because between time 1 and 2, this is the probability that is applicable. So I'll have to first calculate it using this equation. So therefore, price of the option at time 1 is equal to, I know payoff S2 by S1 minus 1 comma 0 into probability. I know probability is S2 greater than S1 because I need to take the probability of 1 to 2 into PV factor, one time step. Now, take this as a pinch of salt for now. We have it in the next chapter, but they are applying, if you see the question, they're talking of something called as EMM, which is equivalent martingale measure, which we'll do in the next chapter. It's coming there. But what equivalent martingale measure says is the rate of change of the underlying asset price stays constant. That means they are saying S4 by S3 will be equal to S3 by S2 will be equal to S2 by S1 will be equal to S1 by S0. All these proportions, the ratio, the relative change in the underlying asset price will stay constant is what EMM says. We'll do it formally in the next chapter. Right now, you can take it as a given thing. Therefore, can I say S2 by S1 is ideally equal to S1 by S0 minus 1 comma 0 into, this will become probability of S2 by S1 greater than 1, which I can write it as S1 by S0 greater than 1 into e raised to minus r is equal to 100 into max of, I know the value of S0 is 1. Therefore, S1 minus 1 comma 0 into probability of S1 greater than 1 into e raised to minus r. With me, everyone, tell your. Now,
Sir, that is probability
can you
of
recognize
S1.
what this thing is? Yeah.
In the second step, it is the probability of S1 greater than S0.
So
Second
that
step.
S0 will come in the denominator on this side, that side it will be 1. Probability of S2 greater than S1 can be written as probability of S2 by S1 greater than 1. So S1 by S0. Cool. This, can I say, looks something like a plain vanilla call option. Max of st minus k comma 0 into probability of st greater than k into e raised to minus r. This is payoff into probability into PV factor of a normal plain vanilla call option. And I know how to solve plain vanilla call option. S0 into phi d1 minus k into e raised to minus rt phi of d2. Using my Black-Scholes framework, we know S0 is 1. The value of k is also 1. I know the time to maturity is also 1 year. I know risk-free rate is 3%. I know sigma is 25%. Use the Black-Scholes formula. Calculate the box part. Once you get the box part, we'll just multiply it with 100. To get the price of the derivative at time 1. This is the last major part. Trust. After this, it's not. Sure. Copy this down. Calculate the answer. Let me know. You all want to calculate it now and finish it off, or should I just explain and then you all will calculate it at home?
We'll do it now.
Recalculate here.
Take it. Chalo, calculate. Now you understand why is it rarely asked. We'll read the comments also if IFO has given any comments on the question in terms of performance. Which question was this? 8030 question 9.
Did this question came in your attempt?
I to give exemption, no?
Still you gave the exam, right?
No. Oh, you're saying at IAQS?
Yes.
Nah, not this. The comment is this question was very poorly answered, obviously, with most candidates unable to cope with part dependent option, even though the steps to the solution were laid out in the question. Familiarity with the actuarial tables would also have been helpful. This is what they've given the comment as. It's majorly a conceptual question. It's
Yeah,
difficult to break it down into two types.
we can attend this if we don't know any other question in the paper. We can just sit and
Yeah.
attend.
Fair. I agree. It's not an easy question. One one three four 1134 7842. Seven, four, two. Therefore, 11.347. Correct answer. Let me know if everyone's getting this. Answer should be 0.11347842. When multiplied by 100 will give you 11.34784.
Sir, value of D1 is 0.24,000.
Yeah. Riya and Bhavani agree. So yeah, that's it.
And D2 is minus 0.005.
Let me know once all are done. I'll then explain the price of the derivative at time 0. Done? Everyone with this part? Now I know if I have to calculate the price of the derivative at time 0, it will be the price of the derivative at time 1 into when will this occur? When the maximum value of ST is less than 2 into the one time step PV factor. We've already calculated this probability. We know this price. A multiplication of all this will give you the price of the derivative at time 0. Everyone understood this part? Calculate and let me know what the answer will be. We are on 10.7. So it's 253. Perfect. That's correct, Tom Ria. So your final answer is price of the derivative at time 1 is 11.347842. Price of the derivative at time 0 is 10.95206. Assuming my probabilities that I calculated. We are done with the question. Let me know if you all have any questions or any doubts. Go back when you all revise. Just look at the overall question, tie it back entirely. Let me know if you all have any questions. It'll take some time to sink in. I just have 1 minute concept that I won't do it today because it's not going to take a lot of time. We'll do it next lecture. That's just a theory concept. It's not numerical or anything. We've already actually seen it as well. If I remember that volatility surface, it's just a concept related to that. So we'll do that in the next lecture. It's going to take a minute only. Next lecture, we'll start with 5-step discrete continuous. So ideally, I don't think I'll need more than 4 lectures now in order to complete the syllabus because as I said, the next 2 chapters are fairly shorter. The next chapter that we have the last chapter, you all have done zero rates, forward rates, spot rates in FIP. That is what one part of the chapter is. Spot rate computation, forward rate computation, zero coupon bond, all of those. So I don't think more than 4 to 5 lectures will be required. Yeah, Ria.
We didn't have FIP, so.
Oh, you all don't have FIP. Okay. So you all haven't looked at zero rates, forward rates. Huh?
Yeah, I have done it, but yeah, we didn't have.
Okay. One more lecture for that. So I think 5 lectures is what I may complete the syllabus in. But as I said, all the significant chapters have been done. The next chapters that we have now have limited numerical questions, relatively straightforward and shorter chapters. So till here, if you have any questions, conceptual questions, let me know over course. But I think now they'll give SRM and all. I think a good chunk is still remaining as part of your syllabus. So this, as I said, will now be like a weekend or however they schedule it. That is how we'll take it. Should I quickly explain the project? Yes.
Yeah, better.
So let me just open the document. Alright, now I can relax now for the subject as it is. Suicide project. Ideally, I left you all 15 minutes early. Okay, let me present the screen of the pointer. Let me know when you have seen this. All right. So the FE project that you'll have is majorly divided into 2 broad parts. There are 2 parts to projects in this particular part, in this particular entire project. I've tried to cover up as many concepts as possible as part of an FE subject. From a practical perspective, I've been doing projects around these kind of concepts around this kind of projects for the last 1 year now. If I'll get into investments, if I'll get into finance, this is what you all may do it very frequently. Even from an insurance perspective, at least the first part of the project is what you are going to do very frequently. Specifically, Ashok, if you get into finance or investment in your jurisdiction, this is what is mandated by CBUA. It's not a mandate or a regulation by RBI yet. It's perceived it may come too soon. But CBUA have already made it a regulation. It's already mandated by all the banks in Middle East to follow this. To follow a model which would actually include this to be computed or this to be performed. Now, if I get into the project specifications, there are two parts to the projects. The first part is something called as risk factor simulation, and the second part is an option pricing technique. So in the first part, what you essentially have to do is you need to predict risk factors. Now, when I say risk factors, I'm essentially saying FX rates, interest rates, commodity prices, equity prices. This is what I mean by risk factors. They're nothing but parameters or asset classes that are happening in the market. So in the first part of the project, you will actually predict your underlying risk factors. So if someone has USD INR FX rate, you all will actually have to predict USD INR foreign exchange rate for the next 3 years. If someone has Reliance share price, you'll have to predict the Reliance equity price for the next 3 years on a monthly interval. If someone has USD interest rates, they'll be predicting USD interest rates for the next 3 years. Now, how do you predict? I don't want to, obviously you can use a regression based model. You can have a practically, these are the different approaches. But considering we are doing an FE based project, I don't want to, you all to use a time series based approach. It shouldn't be a regression based approach. It shouldn't be linear regression, logistic regression, neural network, any of those kind of algorithms I don't want you all to use. What you all have to use is you all will have to use Brownian motion based models. So for example, we have geometric Brownian motion. We have the share price process, ST is equal to S0 into e raised to R minus sigma square by 2t plus sigma bt. All of these are Brownian motion based models. We have our OU process. We did the Vasicek model in our IR process. These are Brownian motion based models. You all will have to use such Brownian motion based models, such stochastic differential equation SD based models in order to predict your risk factors. That's the first thing. Now, I've given you all certain cutoff dates. You all will need historical data because, for example, I have my share price process. I have my parameter mu. I have my parameter sigma square. In my OU process, I have my mean reversion speed alpha to calibrate. You will need to estimate the long-term mean reversion level mu. So in order to estimate all this, you need historical data. So I've given you the cutoff date as on which you can consider. I've given 30th September because there are certain variables that actually get announced or published on a quarterly lag basis. So you may not have the value for December or you may not have the value for Jan. But that is why September I've taken the cutoff. If your variable is not even present for September, it's present, let's say for August or June, you can take that particular cutoff date. But I know for a fact all the variables are present in the, till the time period of September. So that is the cutoff date. You need to predict the risk factor values for the next 3 years at a monthly interval. So you'll have a 36 value prediction from your model. Fair enough? All right. How you will predict? You'll have to do a Monte Carlo simulation. So once you create your model, you estimate your model. Obviously, this is going to test. This is going to, in this project, you will have to use a lot of things which are beyond your curriculum. You all will have to research because Monte Carlo, high chances all may not have used it practically. But what you need to do is the graph, if you all remember, there was multiple simulations. That graph is when I had showed you all once. That is how you'll have to predict. You'll have to use a Monte Carlo simulation wherein for let's say 10,000, 5,000, 50,000, whatever you all select, you all will have to do that many number of simulations for your risk factor. So if I have a 3-year period, if I'm using 5,000 simulation, you will have 5,000 different paths of USD interest rates for the next 3 years. That's the Monte Carlo simulation. So first you will take the historical data, finalize a particular model to predict the Brownian motion based model, estimate the parameters of the model, and then use your Monte Carlo simulation algorithm to predict the values. I don't care whether you use Excel, whether you use Python, whether you use R. Excel, it's not going to be feasible because Python R readily have packages. In order to do this, everything is going to be very difficult for you to do Monte Carlo on Excel. Hence, but I've kept the choice to you. You can use anything. Python and R, you will have readily packages and libraries available. It's fine if you use this because practically no one is going to ask you to do everything for first principles. If there are libraries, you are going to use libraries itself. So I don't care even if you use readily packages, readily libraries that are available. Even for these models, you are going to get libraries that are already configured. You may not have to do everything from first principles. There will be estimation algorithms, everything readily available on Python or R. You all can use that freely. It's up to you all. It's just that ensure you all know what is happening in the back end of that function, not from a coding perspective, from a logical perspective. You should know what the algorithm, like for example, VASI-check is a mean reversion model. You should know that it's a mean reversion based model. This is the SD form of the model. You need not know the coding background or the coding specifications that's happening in the background. I don't want you all to know that NumPy is the library that it's using. It's taking a data frame. It's applying this standardization. No, that is fine for you all to not know. But logically, what is happening in the background, that is something that you should know. Cool. Again, my focus, I don't know if I think I told you all this in FM. My focus is not going to be whether you all use the correct model, whether your simulations are correct or not, whether how much accuracy is in your model. That is the secondary objective for me. The primary objective is how well have you researched the models? How well have you looked at the different models that are available for your risk factors? How well have you understood the models? How well have you understood how to use Monte Carlo simulation, how to apply Monte Carlo simulation? How does Monte Carlo simulation work? All of this is what the primary objective is going to be. How well have you researched and how well you know what you've done? These are the two primary things that I'm going to look for. Reason being, or the objective is, when you go into a room, when you get into the industry after a year or internships, whenever, let's say if you go, whenever you enter into a room, even if they're talking about a model, you should be someone who can at least contribute to that conversation. That time, no one is going to ask you, oh, what was the accuracy that you got from the result? People are going to know whether you actually know in and out of that model that you are talking about. So it's just that whenever you enter into a room, it's not like everything that is being talked about is Greek and Latin. If let's say I'm doing a reserving model, for reserving, I know life insurance reserving. I know I may have to estimate interest rates for that matter. If let's say I have to do a modeling behind that, I know people are going to talk about interest rate models, VASI-check, OU, Hull White. There are going to be these different types of models that are going to be talked about. It shouldn't be like everything is Greek and Latin to you. You should know, all right, this is a model that has these parameters. This is how broadly this model works. So you should be at least be able to have a conversation. That is what my objective is. Hence, accuracy is a secondary thing for me. Primary thing is how well you've researched, what you've researched, and how well do you know what you've done. Fair enough. All right. Anything else do I want to mention over here? All right. Yeah. I think and secondly, whatever you've researched, even if you just come across the model name, you haven't dug deeper into the model, it's fine. Just put it in the presentation that you came across this list of models. At least it shows me how well you've researched the framework, how well you've researched the models, how well you've gone through research papers. Fair enough. Any doubts in the first part? The final outcome, as I said, and include graphs. Include that simulation graph wherein you put all the different parts, different simulations. Put in a graph of your historical data, how your historical data is moving. And whatever you do, put justifications. Like for example, in order to select a model, you will perform some analysis to reject other models. Put that justification, put that analysis as to how do you arrive at that final model. Fair enough. And you should know what the HD of the model look like, what the integral form is, what the distribution of that model. Those are the things that you should know, the way we've done it in academic as well. Share price process, integral form, distribution form, HD form in a similar. Any doubts in the first part of the project? Comfortable? Cool. Now, the second part of the project. And don't just, use ChatGPT as a supplementary tool, but go through research papers. Every model that is there are 10 paper at least that you will find research papers. Some of the research libraries or research websites, SSRN, that's a website that gives research papers. ResearchGate, that's the other website that will give you research papers. Those are the kind of research papers that you can actually go through. They'll actually mention the advantages, assumptions, limitations of every model that you come across. That's the first part of the project. The second part of the project is an option pricing model. So for this, what you'll have to do, obviously, also one thing before I go ahead. Every group, it's a group-based project. Every group has been assigned one risk factor for their first part. So in someone who will have USD interest rate, they'll have to predict USD interest rate. Someone will have INR interest rate, someone will have Euro USD FX rate, so on and so forth. So you'll have to predict whatever is the risk. risk factor assigned to your group. All right. The second part of the project is for every group, I've assigned an exotic option, a pen in American barrier option. This is a barrier option of its kind. Chooser option. If to give you just context, in chooser option, after you enter into the option, later you can decide whether you want this option to be a call option or a put option. That's an exotic option. Swaptions. Compound option. Compound option is an option whose underlying is another option. So it's ideally a call option on another call option, a call option on another put option. So I've allocated in a similar way different exotic options. In the second part of the project, what you need to do is make an option pricing model, make a pricing model for these different exotic options. Whatever exotic option is assigned to your group, you'll have to create a valuation model of that particular option. Again, you can do it on Excel, you can do it on Python, you can do it on R. I don't mind any algorithm, any software that you use. Python R, as I said, high chances one library will already be established, which will price your option that is already there. In order to research, John Searle, S. Penn Gardner. These two books will ideally have the valuation models of all the options that I've allocated majorly. Cool. Another part is, whatever you do in your option pricing model, assume a dummy set of trade details. Take a strike price, take a spot rate, take a time to maturity, take volatility, assume a set of trade detail, get the price. Make your model in such a way that if while presentation, I ask you to change the trade details, you can change that in your code and show me the answer. Reason being, let's assume I have a plain vanilla call option. You did it with a certain set of parameters, you got the price. Now, if I ask you to increase your strike price, I know if K increases, call option price decreases. Ideally, I should see that your option price decreases. So these are the set of checks that you can perform beforehand when you construct your model to ascertain that your model is working fine. Because I know if K increases in the case of put option, my price should increase. That is ideally what your model should also reflect. All right. And take intuitive trade details. For example, if your underlying risk factor is USD INR, don't take the strike price as 200 because I know that is not feasible. So take intuitive trade details, whatever trade details you are taking. Whatever is your first allocation, whatever is your risk factor, that is the underlying that you will assume for your option. So for example, if I have Reliance Industries as my first part, in the second part, the underlying risk factor for option will be Reliance Industries. All right. So whatever is your first part risk factor is what you'll assume to be your underlying asset for your option. Fair enough. Except for people who are going to have swaptions. Swaptions are derivatives which are on interest rates. So whoever gets swaptions, you will assume your risk factor to be any interest rate of your own choice. Whoever gets swaption as part of their group. Assume they won't have HDFC and Airtel as their underlying risk factor for options. For swaptions, you'll assume any interest rate of your choice for the underlying asset. Fair enough. That's the second part. As part of deliverable, you will submit one single presentation PPT, which will explain both the parts of your project. You will submit all your coding scripts, Excel, Python, R, whatever you've done, you will submit that. As part of the presentation that I'll take similar to FM, you will use your PPT in order to walk me through your entire presentation. Cool. Any doubts? Any views?
Interesting.
Interesting. At outside, he felt it's quite difficult, but we will do the research and we'll try to do our best, whatever we can. But
As I
once
said,
more,
I don't expect you all to have 100% accuracy, but how well you have researched.
yeah, we do our best. And one small request, I think the admin will allocate the teams, right?
Yeah.
But you might have seen how regular we are, and there are a lot of irregular people. And the last time I struggled personally, and even some of them did not attend the final presentation as well. So just ask them to consider this factor when they are making the teams. But by the way, how many teams they will be making it?
I am thinking I'll have 4 teams. You all are how many? 16 people, no?
20, I think -2. 2 already discontinued. 18 it will be, I guess.
So not, yeah, I think 4 groups. If I take 5 groups, it's 4. So 2 groups will have 3, which is low in terms of the project. So I think 4 groups, because ideally the way you'll divide resources is 2 and 2, so that both of the parts go in parallel. So 4 groups, 2 groups will have 5 people, and the next 2 group will have 4 people. So 4 groups. Yeah, I think 4 groups should do it.
I mean, each group, at least if there are 2 regular team members who attend the class and all, so that will help in a way.
I know
So
this is always, even in BSc MSc, this is a concern. That is why I just put this as a commit and send it to them as to whatever they want to do, however they want to do it. But I'll bring this point across.
Please, that will help, because in last time when I was doing the project, I was the only regular guy, and I have to teach them literally what they have to present, and I have to explain everything because they don't do their own research. At the
Yeah.
end, we have to think as a group.
Fair. I'll bring this point across. But yeah, actually, if it's 4, then I'll have to also tell them which risk factor and this are not. Cool. Okay. This I'll make the point across. Deadline they'll update, as I said. I don't get into all of that. But there's enough time to take the presentation also. So that's fine. Cool. Any doubts you all have? Once I'll get the project, go through it. Let me know after getting it if you all have any questions. I can answer those accordingly.
What's the timeline? What's the time deadline for that?
I don't get into all that. Admin will take care of that as to however they do it. So
Before
once the project
final
is
exam or after the exam?
no, after exam it's not going. You all may probably have a 20-day period, probably, based on how they allocate, and the presentation also will be before exam. I don't last time though, because all the subjects were rushed, that's why it went post exam. But I generally prefer to take it before exam. Reason being that post exam is purely for your break and relaxation and to prepare for the next set. So I generally don't like to eat up that portion of, because considering even I was on the other side, I know how it feels when that time has been taken. So I generally prefer it to take it before break. And y'all can actually make plans. People who are specially working, y'all can actually make plans only in that period of break because y'all don't have lectures. So that is a time that I don't generally like to hamper with. Even in offline, people generally go outstation, go back to their homes. So that is the period I generally don't like to take presentation and to make that as an obligation. So generally, it's just going to be 1 day or 1.5 hours because it's just 4 groups. So it's just like 20 minutes of your time. So before exam only, I'll just complete it.
But on the other hand, we have to research, we have to read, we have to work, and we have a lot of heavy subjects. So after exam would be better.
Let's see, because after exam also means that your results are going to be then delayed. Because once I give the project marks, it goes through the approval phase. The marks gets locked in if there are no changes, and then it gets feeded into the results. So that also means a change in timeline for your mark sheets.
For me, before the exam is better, Abdul, because we do a lot of research on these concepts. Then it will help us in writing the exams as well.
Exams also, yeah. Because this actually brings in clarity in your concepts when you do.
Yes.
Like, for example, if you research on GBM, the formula actually fits into your mind and that becomes easier to remember the equations for your exams as well. That I agree.
Fair.
Okay, let's see. But I think even the admin will prefer to take it before exam, considering it's going to get allocated in the coming week only. So y'all, like, there are 2 months, so even they wouldn't prefer it to post it till after exams. But timelines and groups, that's why I don't get into all this ambiguity. I let it be between students and admin. The day they tell me to take the presentation is the day I get on call and take the presentation. Those option pricing. I'm just taking your attendance quickly. Those option pricing model type. Without class. Bhavani present. Ashok present. Priya present. Anushka present. Abdul Rahman present. Tom present. I think that covers everyone. 1, 2, 3, 4, 5, 6. Yes. Cool. Thanks, guys. Enjoy your rest of the weekend. In case we don't meet on Monday, happy Holi to all of you. Enjoy.
We are
And we'll
celebrating
meet you.
Diwali.
Sorry.
We are celebrating Diwali here.